Okay, so in the first question, we're obviously using the idea that m equals tan theta. And we also have the fact that the angle is 30 degrees. So if m equals tan 30, then to do this without a calculator, there's something in maths called your exact values of trig functions. Now, it depends on whether or not you've been shown this from National 5. So there's two ways of doing it. When I was at school, I was just kind of given this big long table to memorise, basically. So the values which we have exact values for are 0, 30, 45, 60 and 90, and then we can obviously work out others after that based on the related acute angle. And then you've got sine, you've got cos, and you've got tan. And sine of 0 is 0, and sine of 90 is 1. We already know that. Sine of 30 is a half. You might remember that one. And then the other two are 1 over root 2 and root 3 over 2. Okay, and then cos does the opposite. So cos of 0 is 1. Cos of 60 is root 3 over 2. So we're going backwards over the row above. This one's 1 over root 2. This one's a half. And this one is 0. Tan's totally different. Tan of 0 is 0. Tan of 90 doesn't exist. If you think about the tan graph, that's where there would be an asymptote. And then tan of 30 is 1 over root 3. Tan of 60 is root 3. So that was how I used to remember them. The smaller one was 1 over. And then tan of 45 was 1. So those are your exact values that you need to memorise. Now there is another way of memorising them, which is called your reference triangles. And I'll probably make up a wee separate video to do with that. But from here, for tan of 30, that's what we were being asked to work out. So tan 30 is 1 over root 3. So we would end up with the gradient being 1 over root 3. And then from there, you'll be able to get the perpendicular gradient and get the equation of L. But I'll make up another wee video about exact values, which will hopefully help. But this table here is what you need to memorise. And it's up to you whether you memorise that table or you use the method that I'm going to show you. In fact, I'll just show you it now because we have space on this video. So what we are going to do is we're going to look at two different triangles, and this is where these exact values come from. One of the triangles is an equilateral triangle where the sides are all 2, and the other one is an isosceles right-angled triangle. Okay, so if we cut this first triangle in half, then we're only looking at this right angled triangle here. We're going to look at that. So if I draw another triangle to represent that, then this bit at the bottom here now is clearly only 1. Okay, the hypotenuse is 2. And the height here, if we did Pythagoras, we would get root 3. Okay, now if we fill in the angles, this angle down the bottom here would be 60 degrees. So this is 60. And the one up here would be 30 because it's half of 60. So this is 30. And then from there, you need to think about your whole SOHCAHTOA. So if I want sine of, if I want sine of 30, say, then sine of 30, here's the 30. So I'm looking for opposite. There's my opposite over hypotenuse. So that's why sine of 30 is opposite over hypotenuse. It's 1 over 2. Equally, if I wanted tan of 60, say, tan of 60, so here's my 60. Tan is O over A, so opposite is this one here, root 3. Adjacent is there, so it would be root 3 over 1. So that's a wee bit messy, but hopefully you can vaguely see where that's coming from. Okay, and we can do a little bit of practice of that if necessary. The other triangle we've got is the 45-degree triangle. Okay, with our isosceles, so these two lengths are the same, which means the two angles are 45. These two lengths are both going to be 1, which means our hypotenuse is root 2, again from Pythagoras. So here, if I was asking you what cos of 45 degrees is, you can pick either angle, it's not going to matter. 45, we need cos is adjacent over hypotenuse. There's my adjacent, there's my hypotenuse, and that's why the exact value would be 1 over 2. Some people like to use these reference triangles. Okay, to help them, you would draw the triangle out in the exam to help you get the correct values. If you've got quite a good memory or you prefer the table, you might want to use the table. It's totally up to you, and we'll do a little bit more work on that.